Hello everybody, I will start my today another coding session. So today I solve this question. Longest substring with at most k distinct characters. Yeah. Giving a string s and an integer k, returns the length of the longest substring of s that contain at most k distinct characters. Okay. So let me clarify my understanding first. So in this question, I'm giving a string s, and also I'm giving a string integer k. And I will return the length of the longest substring of s. I will return string. Okay. No, length, so I return the number, which is the length. Okay. So this is the interface. And I will think of the constraint. So what I'm wondering first is how long s can be. Can s be an empty string or not? So s can be empty string. Yep. And for k, there should be positive or 0, I think. Yep, true. Okay, so it never becomes -1 like the invalid number. Okay, and aside from that, I'm wondering, S consists of which characters? Like only English lowercase characters, or maybe it can include Japanese hiragana, Chinese characters, or something. I have no idea. So I would say many types of chairs. So what I was thinking is, if this consists only of the English character, I can just create the hash map or something. And traversing each character takes only 26 steps. So I can think of it as a constant. But in this case, a hash map may have so many keys. Yeah, so that's what I found from this. Okay. Yep. Now we'll take a look at an example. So let's think with a case like this. Yep. So obviously, what I can do as the brute force approach is that I will check every possible string and check how many distinct characters there are, and because I return the longest substring length, so yeah, I return the longest one. So that's the brute force approach. So it takes, let's assume that the string s has the length n. In that case, it should take n squared for choosing start and end of each substring, or I should say there should be n squared in bigger notation, the number of possible substrings is O of n squared, and for each it takes O of n to count the unique characters. So it should be n cubed. Yeah, but I'd like to optimize this more. So yeah, I'm thinking of using the 2 pointers here. So let's say the substring which ends at this A. So this is valid, yeah, because it has only one unique character. Let's think of the case B. AB has only 2 characters. It's fine. I can still use this. And let's say ABC. This is invalid because it has 3 characters, unique characters, ABC. So I shrink this beginning, yeah, left pointer. And now I've got BC, which is good because there are only 2 unique characters. Now I expand this to BCC. Yep, I don't have to move this B because if I mean, I don't have to move this left pointer. I can start it from the current position when I move the right pointer. Because if left pointer is moved only if the current left position causes an invalid state. So if I move it back, it causes an invalid state again because the left is, rolled back, which has more characters, and right hand side, right pointer, also have more character because I moved it. So it causes the invalid state. Yeah, because in this example, this was invalid, so I shrink this left pointer. So I can say, definitely this is invalid. So that's why I don't have to move the left pointer. And I can start from the current left position. Yep, that being said, now BCC, it's fine. Only 2 characters. BCCB, this is valid because there are 2 B's and 2 C's. Here is still valid. Oh, no, I moved this one. And here, this is invalid because it works like this. So I keep shrinking the left, I keep moving the left pointer. So I pop out B. And here, I have only one. They're invalid, so I move it again. And now C is popped out. They're invalid. And move it again. And now, because C is 0, I can delete this key. So I can say there are only 2 unique characters. So this is not valid. So let me say what I should do. I've already seen a lot, so I can now sort it out. What I can do. So use 2 pointers, left and right, and for each right, shrink left pointer as long as it's invalid. Yeah. Then after moving the left pointers, now update return ranks with current length, which is left, right minus left plus 1. And I return the rate, which should be the global maximum rank. Okay, so this is it. So in this way, I use the threading windows approach. So time compressed this should be O of n. I move the left pointer and right pointer. Each of left and right could move up to n steps. So in total, it should be n plus n is O of n. For space compressed, I need the hash map, which is like this. So in the worst case, all the characters in the given string is different. In that case, there are n unique characters. And let's say k is equal to n. In that case, I keep moving the right pointer without moving the left pointer at all. And all the characters are stored in the hash map. So it should be n keys. So the space complexity is O of n in the worst case. Okay. That being said, I've started the implementation. So here, I need the hash map. But if S right doesn't exist yet, I append it. So, or I can use the counter here. Yeah, but let me do not use the unit. So for now, I use this one. So if in that case, I define it, then anyway, I increment it. So now I can say while the key number of the key is more than k, I have to keep shrinking. The left pointer should be moved. But before moving it, I have to pop out this character sreft from chair count. And here, I use the number of keys of this hash map for this while loop condition. So if the value becomes 0, I have to delete the key. Like this. Okay, so I move the left pointer as rare as possible. Then here, current ranks is like this, and return global max ranks. And I return the max ranks in the end. Okay, this is it. So now let me see. Do I run my code? So as the edge case, let's say S is something like this, and K is 0. In that case, I expect, because the substring can't have any character, because K is 0, 0 should be returned. So let me check it. So left should be 0 first, and right should be 1. No, sorry, index 0 first. Then now in line 57, S right, which is A, is not in the chair count, so key A is created with 0 and it incremented after that. So now it should be A1. In line 61, ranks of the chair count is now 1, which is more than K. So I move the left pointer now. But before moving it, in line 62, chair count, key A, is decremented. So this becomes 0. And in line 64, the key should be deleted. So it's now empty hash map. And I move the left pointer by 1. Okay. And in line 61, ranks of the chair count is now 0. So, and k is 0. So I go to line 67. And right minus left plus 1 is 0 minus 1 plus 1 is 0. So current ranks is 0. So max ranks becomes 0, 0. Okay. And I come back to line 56. And right is now 1. And quite the similar thing happens here. B is not in the hash map, so key B is created and incremented. So now it should have B1. And in line 61, because chair count ranks is 1, I go to line 62 and B should be popped out, decremented. So this becomes 0. And now in line 64, this key should be deleted. So now it's the empty hash map and the left pointer is incremented. Okay. And in line 67, current ranks is right minus left plus 1 is 1 minus 2 plus 1 is 0. So max ranks is not updated. There's 0. Yep. And I is the end of the for loop. So in line 70, I return 0. Okay, so I actually passed this test case. Good. So I'm pretty confident in my code. Actually, even though I checked only the base case, I could cover all the lines. So probably I should be checking some more cases like ABA and case 2. No, sorry, case 1. In that case, when right is at B, this A should be decremented. Yeah, but I don't do it here because to save my, in order to save my time, let me submit. Good. Okay, accepted. Great. So, yep. Let me quickly wrap up. So today I said the question, longest substring with at most k distinct characters. So this is a quite typical threading window question. So I can solve this question with linear time complexity. So basically, I move the left pointer and extend the current substring. And if the current substring has more than k unique distinct characters, then I move the right pointer. Sorry, I move the left pointer. Sorry, I move the right pointer and expand the substring, and I move the left pointer as little as possible to shrink the current substring so that it doesn't contain more than k distinct characters. Yep. And every time after moving the left pointer and the current substring becomes buried, it should be the longest substring with the end index is equal to the current right position. So I update the global maximum ranks, which should be returned in the end with the current that ranks. Okay, so that being said, I finished my today's coding practice. Thank you so much. Bye.